So first of all, in terms of classifications, a few that we've picked out here are those listed here. And it's very important, or we chose to talk about these different classifications because they sort of lead to the underlying bases for the different controls that we are, as an industry, subjected to. So, okay, first is the composition. I think we're all familiar with these. So you have pure refrigerants, then you have mixture or blend refrigerants, which are then divided into two categories: azeotropes and zeotropes, which tend to have larger temperature glides. And the characteristics of these different types of substances obviously affect our refrigerant choice. And also chemical structure, or the sort of chemical components of the substances. So we're familiar with HCFCs and CFCs, also HFCs, which all contain hydrogen, fluorine, and carbon, or chlorine, fluorine, carbon, and so forth, hydrocarbons as well. And then we have the HFOs, which are becoming more widely used, which are unsaturated HFCs, and there's a couple of others there, HCFOs, which are hydrochloroolefins, so unsaturated HCFCs, and HCOs, which are hydrochloroolefins, also unsaturated molecules. And these are relevant because they influence a lot of legislation that we will discuss later. There's the safety class, which you're familiar with, relating to flammability and toxicity. I'll discuss that in a bit later. There's the UN Global Harmonized System, or GHS, and that deals with, in a similar way, safety class, so different safety classes. This is actually more of has a legal basis, or is integrated more into legal requirements legislation than the ISO safety class. And then there's the global warming potential, which is obviously one of the factors that dictates what we're doing with refrigerants today. Just touching on the ISO 817 safety class, as I say, it's the conventional safety class is broadly well known. That is dealing with flammability ranging from class 1 to 3, being non-flammable to higher flammability, and toxicity A and B being lower and higher toxicity. It's also in recent discussions with the broadening of boundaries to look for alternative refrigerants. Some companies are considering less stable substances, and this will be discussed in more detail in a bit. But these stability issues affect the can obviously affect the safety of the system. And so there are new stability classes being proposed, alpha, beta, and gamma, ranging from conventional stability that we're used to today to very unstable refrigerants. Consequence of this, of course, is that the refrigerant classification may become a lot more complicated. So you can see it might range from A1 alpha for lower toxicity, non-flammable, high stability, to B3 gamma being high flammability, high toxicity, catastrophically unstable. So obviously this will then have implications on how the equipment standards are revised as well. But it's obviously, this is all important stuff when considering refrigerants for the future. We also mentioned global warming potential, and